we have a convex lens, and we have a concave lens as well. So let's start with lenses. Okay, अब lenses में the first one is a convex lens, and this convex lens is also called as a converging lens as well. Converging lens. So converging lens जो है आपके पास, अच्छा, lens is basically it's made from a glass, right? So ये आपके पास एक, we have this glass lens, ठीक है, which is thin at the edges and which is thick at the center. Now, what is a converging lens? A converging lens is basically a lens when the rays of light are incident on a lens, on this converging lens. So these rays of light, they are converged at a single point. Okay? So आपके पास, we have a parallel rays of light, and what happens कि these parallel rays of light, they are converged at a single point. So this is what happens to these rays of light. Okay, ठीक है. So what is basically a convex or a converging lens? A lens which is thin at the edges and which is thick at the center. So lens is thin at edges and thick at center. Thick at center. Second point is that the rays, the parallel rays, are converged at a single point. The parallel rays are converged at one point. Acha beta, please, if you have any questions, so you can drop me a text on the WhatsApp. Okay? The parallel rays are converged at one point. Okay, now this is a convex or a converging lens. अच्छा, जो lens होता है, the lens is made from glass. The lens is made of glass. Okay, now one more thing, beta. Now, if this is your convex or a converging lens, now let's just quickly talk about a concave or a diverging lens. And इसमें कौन सा phenomena ये follow कर रहा होता है? It follows the phenomena of refraction. Okay? So refraction is taking place. So the second type of lens we have is a concave lens, also called as a diverging lens. Acha. Now the concave lens or the diverging lens is thick at the edges and it's thin at the center. So this is how okay. So ये थोड़ा मतलब मेरे से थोड़ा ज़्यादा ही वैसे हो गया, but it's fine. So its lens is thick at edges and thin at center. एंड जो पैरेलल रेज आपके पास इनकमिंग होती हैं, so they are diverged. Okay, so let's say we have these parallel rays of incoming. So let me draw the diagram of this diverging lens. Diverging lens again. Okay, let's just quickly correct it again. Okay, here, this one is fine now. Okay, so this is the center of the lens. Okay, this arrowhead is for the diverging lens. So we have parallel rays of light. So what happens when these parallel rays of light, they are incident on the diverging lens? So what will happen? They are going to spread out. Okay? So, so let's say these rays of light will just spread out like this. ये आपके पास spreading हो रही है. Such that when you will extend these rays of light backward, so they will meet at the backward. जो इसका पीछे focal point होता है, ये वहां पे meet करेंगी. Okay, so you can see the parallel rays of light, they are diverged or they spread out. The parallel rays of light spread out. तो ये spread हो जाती है, and when you extend those rays in the backward, they will meet at the जो left पे focal point है, they meet on the left of the focal point. This is how the आपके पास concave lens looks like. Acha, now one more thing that we need to remember about both the lenses is that refraction takes place. ठीक है? So these lenses, they undergo the phenomena of refraction. Okay. Refraction occurs in lenses, whether it's a concave or whether it's a convex lens. So refraction is the one responsible for that. So refraction occurs in lens. Why refraction takes place? Because glass is a different medium and the air is a different medium. So as light travels from air into glass. So the light is basically traveling from the air into the glass, ठीक है? So causing the speed and the wavelength of light to decrease, which eventually cause the bending of light waves as well. So refraction occurs in lens as light travels from air into glass. Its speed and wavelength decreases. So why the speed and wavelength decreases? Speed and wavelength decreases because glass is a denser medium and air is less dense because glass is denser and air is a air is less dense medium. So this is how a concave lens looks like. Okay, when a parallel rays of light they are incident on a convex lens, those rays will converge at one point. If a parallel rays of light are incident on a diverging lens, they just simply spread out. Okay, lenses are made from glass. Refraction is taking place because when the light travels from air into the glass, so its speed and wavelength will decrease because the glass is a denser medium and air is a less dense medium. Okay, now let's just talk about the next thing, and that is the basic terms of a lens. So let's say basic terms of any lens. So let me draw. So this is a convex lens now. ठीक है. अच्छा, अब बेटा सबसे पहले तो we have a optical center of the lens. This point, which is actually the geometrical center point of a lens. So this point is called as the optical center of a lens. Acha, if any ray of light travels through the optical center, it will pass straight through. ठीक है? A ray of light passes straight without getting deviated. ठीक है? So a ray of light passes straight through this point. Through this point. So this is the significance of an optical center of a lens. So let's say if a ray of light is incoming, so it's going to pass straight without getting deviated. Okay. Now similarly, let's say if this is the ray of light that is incident and passes through the optical center, तो optical center से जो ray of light है, it will always pass straight without getting deviated. Okay, so this is the significance of an optical center of a lens. So this is how it just looks like. Okay, now what is principal axis? So that was the first thing, which is the optical center. Now let's just talk about okay, what is a principal axis. Okay, so that is your convex lens. So principal axis is basically a horizontal axis which passes through the optical center of the lens. So this horizontal line is basically your principal axis. Principal axis. So it's basically a horizontal line that passes through the optical center of your lens. ठीक है? Horizontal line passing through optical passing through optical center. Acha. Acha, if you have any question, please just drop me a text in the WhatsApp. I'll respond back to you from there after reading it. Okay, so we have the principal axis now. Now, what is a focus? Principal focus? ठीक है. Now, principal focus is basically a point कि if we have a principal focus on both sides of the lens, we denote it with capital F. Okay. Now this principal focus, and this is the optical center. We denote the optical center with capital C, and we denote the principal focus with capital F. So this is a principal focus. अच्छा, principal focus का ये है कि if a parallel ray of light, if a ray of light which is parallel to your principal axis is incident on the lens, it will pass through the principal focus. Okay? So this is how, let's say if you have a, yeah, this is how it looks like. So principal focus is कि a ray parallel to the principal axis will pass through the focus, principal focus. A ray parallel to principal axis is incident on lens pass through principal focus. We call it principal focus or focal point. Focal point, and it's denoted with capital F. Now the distance between the principal focus and the optical center of the lens is called as the focal length. So focal length is exist on both sides of the lens. Okay. So this is your focal length. Focal length. Now what is focal length? The distance between the optical center and the focal point. Between F and C. That is your focal length. So these are the general basic terms: optical center, principal axis, principal focus, focal point basically, or the focal length. Okay, these are the general things that we need to know. और सबसे important चीज़ें ये है कि if a ray of light travels through the optical center, it will always pass straight through without getting deviated. If a ray of light is parallel to the axis, so it will always pass through the focal point F. अच्छा, for a convex lens, आपके पास जो लेफ्ट पे अगर रे है तो आपके बाद में the ray will pass through the focal point on the right. Diverging में उल्टा होगा. ये अभी हम image formation discuss करते हैं. So we'll have a clear understanding of this. Okay. So let me. Okay, so let's just talk about the image formation now. how to produce an image. Okay, so let's just talk about the image formation. अच्छा, image formation के लिए अब हमारे पास बेटा we have 6 different cases और उसमें we will also talk about के ये image की characteristics जो हैं वो क्या होंगे और उनकी applications भी हम देखेंगे कि what are the applications for those particular ones. Okay, so image formation in convex lens. So we'll be talking about those 6 different cases. 6 cases. Now you don't need to memorize those cases. ठीक है, उसकी एक ट्रिक होती है, प्लीज आप वो याद कर लो। मतलब तो वो बाकी के सारे लेंस की जो मर्जी डायग्राम आपको एग्जाम में आ जाए, so you will be able to do that inshallah. Okay, so let's just talk about the first case. ठीक है, I'll tell you about the, so let's say we have this lens. So we have this convex lens. That is your convex lens. So सबसे पहले हम एक लेंस ड्रॉ करेंगे। उसी तरह आप सबसे पहले बेटा प्लीज मार्क द एक्सिस एंड एवरीथिंग. Okay, so that is going to be the, this is your principal axis. Mark the focal points. Focal point जो है, focal point will be equidistant on both sides. So let me mark the points F एंड इसको थोड़ा और एक्सटेंड करते हैं. मैं एफ और 2F दोनों पॉइंट्स को मार्क करने लगा हूं. ओके, सो लेट्स से ये आपने, ये 2F वाला यहाँ पे होगा. अच्छा, अब केस क्या होगा? ठीक है, ओके, सो वी हैव दिस लेंथ. अब देखो आपके पास बेटा ये एक ऑब्जेक्ट है. ठीक है, तो केस 1 हमारे पास ये है कि जो ऑब्जेक्ट है ना, ऑब्जेक्ट इज प्लेस्ड बिटवीन द फोकल पॉइंट एंड द optical center. So the first case is the object has been placed between the point F and the point C. Now let's see how we are supposed to draw the diagrams. ठीक है, और let's just draw these diagrams as well. अच्छा, सबसे पहली चीज आपने इसमें ये करनी है कि आपने ना लेंस के टॉप से, ठीक है, so लेंस का, this is the top of the lens and this is the optical center. So what we need to do is हमने इसको एडजस्ट करना है. या ठीक है, अल्हम्दुलिल्लाह. ओके, सो व्हाट वी हैव टू डू इज, अब आपने एक बिल्कुल सीधी रे ड्रॉ कर देनी है फ्रॉम द टॉप ऑफ द ऑब्जेक्ट एंड पास इट थ्रू द ऑप्टिकल सेंटर ऑफ द लेंस. सो ये हमेशा ही है आपके पास. ठीक है, सो फर्स्ट स्टेप हमेशा आपने क्या करना है, ड्रॉ ड्रॉ अ रे फ्रॉम top of object and pass it through optical center. Optical center, optical center of lens. सो हमेशा फर्स्ट स्टेप आपका ये होगा. अब दूसरा स्टेप ये है कि यू विल ड्रॉ अ रे which is parallel to the axis, and then you have to pass that ray through the focal point F of the lens. ठीक है? So now we need to, okay. So let's just draw this ray as well. Okay? अच्छा. तो अब दूसरा दूसरा क्या होगा? दूसरा ये है कि ड्रॉ a ray parallel to principal axis, principal axis, and pass through focal point, through focal point on right. अच्छा, ये these are the key steps for any ray diagram that you want to do. तो आपको एग्जाम में जो मर्जी रे डायग्राम ड्रॉ करने के लिए आ जाए, तो बेटा यू जस्ट नीड टू मेक श्योर ऑफ दीज थिंग्स कि एक रे आपने ड्रॉ करनी है फ्रॉम द टॉप ऑफ द ऑब्जेक्ट and pass it through the optical center, and then you have to draw another ray which is parallel to the axis and pass it through the focal point F. Now let's say if the rays do not meet on the right side, then extend the rays backward. Okay? तो अगर ये रेज जो है ये राइट साइड पे मीट नहीं कर रही, इंटरसेक्ट नहीं कर रही, कट नहीं कर रही, तो इनको बैकवर्ड एक्सटेंड करो, एंड वेयर दे विल मीट इज गोइंग टू बी द इमेज पॉइंट. ठीक है? सो द थर्ड पॉइंट इज कि इफ रेज डू नॉट मीट on right, extend rays backwards until they meet. Okay, now let's just extend these two rays in the backward direction. So इनको इन्हीं rays को हम so I am going to draw. Okay, now let's just extend the other ray as well. Okay, now extending, अब आप देख रहे हो सेम रेस को आपने बैकवर्ड एक्सटेंड कर देना है कि such that they just meet at one point. So the point where they intersect is actually your image point. Okay? अब मैं इसको vertically so ये यहाँ पे मीट कर रही हैं, तो ये मेरे पास this is your image point. ओके? तो ये आपके पास इमेज का पॉइंट बन जाएगा. ठीक है? तो बेटा whenever you have to draw any ray diagram, तो सबसे पहले ऑब्जेक्ट के टॉप से पास अ रे थ्रू द ऑप्टिकल सेंटर स्ट्रेट. यहाँ से मैंने बिल्कुल एक सीधी रे ड्रॉ की. देन ड्रॉ another ray which is parallel to the axis, and after passing through the lens, pass it through the focal point F. If these two rays they do not meet on the right side, extend these rays backward, और जहाँ पे ये backward meet करेंगी, that is going to be the image point. So this is your image. Now let's just talk about के what will be the characteristics of this image. So what are the characteristics? अच्छा, सबसे पहली चीज कि whether it's a real image or a virtual image. तो बेटा please remember, if image and object is on the same side, then it's a virtual image. ठीक है? So पहला पॉइंट आपके पास ये एक virtual image है. Why is it a virtual image? Because object and image on same side. ठीक है, ऑब्जेक्ट भी लेफ्ट साइड पे है लेंस के, इमेज भी लेफ्ट पे है लेंस के. ऑब्जेक्ट एंड इमेज ऑन सेम साइड. अगर ऑब्जेक्ट लेफ्ट पे होता एंड द इमेज was on the right, then it would have been a real image. Okay, the other one is कि अगर तो इमेज का साइज ऑब्जेक्ट के साइज से बड़ा है तो इट्स अ मैग्निफाइड. अगर इमेज का साइज ऑब्जेक्ट के साइज से छोटा है then it's a diminished image. And if the size of the image is same as the object size, so then they are equal sizes. So we can say कि this is magnified image. Okay, so we have a magnified. Okay, third one is कि whether it's an upright or an inverted. Upright तब होता है अगर तो ऑब्जेक्ट और इमेज दोनों एक्सेस से ऊपर है तो देन इट्स अपराइट. ठीक है, अगर ऑब्जेक्ट इमेज से ऊपर एक्सेस से ऊपर है एंड द इमेज इज बिलो द एक्सेस, सो देन इट्स इन्वर्टेड. ठीक है, so it's an upright image. Why? Because object and image, they both are above the principal axis. Object and image above the principal axis. Okay, so these are the characteristics of any image. And if you, let's say, if you want to find out the magnification, the magnification is going to be the image height over the object height, or the distance of the image from the optical center divided by the distance of the object from the optical center. So HI, let me denote HI, it's the image height, and HO as the object height. So how do we find out the linear magnification? Magnification, we denote the magnification with M, and that is image height over object height. Or you can just simply use distance of image from the optical center divided by the distance of object from the optical center, and that was the first case that we have done. अच्छा, now इसी को as a basic principle use करेंगे, and we will just solve the other cases as well. Okay, so now let's just talk about the other cases. Okay, okay, मैं चाह रहा था कि ये इधर हो जाए कॉपी. ओके, इट्स ओके अगर ये नहीं हो रहा तो. अच्छा, we'll draw the another, वो मैं बना लेता हूँ. Okay, so now let's just talk about the second case. So again, we have converging lens, and or we call it a convex lens. So we have to draw the axis as well. तो सबसे पहले तो मैं we have this. Now let's just draw the principal axis such that this principal axis will pass through the center of your lens. This is your principal axis. ठीक है. This point is the optical center C. Let me mark this as the focal point. मगर please make sure कि on both sides जो focal point है, it should be at the same distance. Okay. अब पहला केस हमने ये किया था, we placed the object between the focal point and the optical center. Now what we are going to do, we will place the object at the focal point of the lens. So this is the object. Acha, now we have to draw the rays. We will follow the same procedure. ठीक है. What was the procedure? Procedure वही जो हमने मैंने ऊपर instructions में लिखी थी कि सबसे पहले तो you have to draw a ray, ठीक है, which passes from the top of the object and through the optical center, and then you have to draw another ray which is parallel to the principal axis, and then it passes through the focal point F. So let's just do that. So let's just pass one of these rays from the top of the object and through the optical center. Okay, so this is how the, okay, so draw one ray, या आपने एक रे ड्रॉ करनी है from the top of the object and pass it through the optical center. Then you have to draw another ray which was parallel to the axis and then pass it through the focal point F. ओके. अच्छा, अब अगर आप बेटा गौर करो, ठीक है, सो इफ द रेज दे डू नॉट कन्वर्ज, ठीक है, तो अगर तो रेज जो है इफ दे डू नॉट मीट ऑन द राइट, तो देन माय थर्ड इंस्ट्रक्शन वाज कि एक्सटेंड दीज रेज इन द बैकवर्ड डायरेक्शन. इन्हीं दो रेज को आप बैकवर्ड एक्सटेंड करो एंड extend them until these rays they converge at a point. So, okay. अच्छा, अगर आप गौर करो तो the rays of light, these rays just they just become parallel to each other somehow. So if these rays are actually, if they become parallel, तो अगर मैं इन्हीं rays को backward भी extend करूं तो बेटा these rays are never going to meet. So what is the second case? Second case is कि object जो है, object is placed at the focal point F. And you can see कि अगर मैं इन्हीं रेस को मैंने मैंने दो इंस्ट्रक्शंस दी थी ना आप लोगों को कि first you need to draw a ray that passes from the top of the object through the optical center, then draw another ray which is parallel to the axis and then pass it through the focal point. If they do not converge on the right, then extend these rays backward such that the point where they are going to meet is going to be the image point. Okay? नाउ अब अगर मैंने ऑब्जेक्ट को फोकल पॉइंट पे रखा है एंड मैंने वही इंस्ट्रक्शंस फॉलो की हैं तो द रेज जस्ट बिकम पैरेलल. ओके, एंड सिंस द रेज दे जस्ट बिकम पैरेलल, तो इफ आई एम गोइंग टू एक्सटेंड दीज रेज इन द बैकवर्ड डायरेक्शन एज वेल, सो दे आर नेवर गोइंग टू मीट. ओके, सो अच्छा, बट ये अब पैरेलल ये बैकवर्ड्स जाती जाएंगी और कहीं इन्फिनिट पॉइंट पे जाके आपकी वो इमेज जो है ना वो फॉर्म होगी. So what will be the characteristics of this image? So the characteristics, first of all, it's going to be a virtual one. So इस image की characteristics आपके पास है कि it is a virtual image because ये right side पे image नहीं form हो रही, image still is being formed on the left side. Secondly, image जो है it's going to be magnified क्योंकि infinite में backwards जाके कहीं ये meet करेंगे तो आपके पास image जो है it's going to be magnified. And the third one is कि image is going to be upright. इसके characteristics जो है it's exactly the same as the previous one. और इसकी एप्लीकेशन क्या है हमारे पास? The application of such type of lens is कि to produce a parallel beam of light. ठीक है. So to produce a parallel beam of light. और जो ऊपर वाला आपके पास थी जिसमें वर्चुअल इमेज वाज बीइंग फॉर्म्ड और इमेज मतलब एक जगह पीछे बैकवर्ड एक्सटेंड होके मीट कर रही थी रेस, उसकी आपके पास एप्लीकेशन क्या थी? उसकी एप्लीकेशन ये थी कि दैट इज यूज्ड एज अ मैग्नीफाइंग ग्लास बिकॉज आपके पास जो इमेज पिछले वाले केस में भी फॉर्म हो रही थी इट वाज मैग्निफाइड अपराइट and it was virtual. So that is used as in a magnifying glass. Okay, so we'll talk about the other four cases in the next class, and we'll also talk about the short sightedness and the long sightedness as well.